Hi, Algebra students. This is Ms. Carranza here. Today we're going to talk about Section 8.4, Solving Quadratics by Factoring. Please take a minute and write down the title of this lesson on a separate sheet of paper. 8.4, Day 1, Solving Quadratics by Factoring. Pause the video if you need more time. Okay, when you're ready, I want to review how to graph quadratic equations. In order for us to graph a quadratic equation in standard form, we needed to identify three numbers first. The value of a, which is the coefficient of the x squared, the value of b, which is the coefficient of the linear term, and the value of c, which is the constant value. We then set up a table where the middle value was called the vertex. Now the vertex, for the x value, we used a formula. For the vertex, we used a formula. We took the opposite of b and divided by 2 times a, and that's from our values of a, b, and c. So if you take the opposite of b, which was -4, you take the opposite of that, you get 4, and divide it by 2 times a, which was 2. 4 divided by 4 is 1. So our first value of our table is 1. To find the y value, we substituted the value of 1 into the original equation, which was 2x squared minus 4x minus 6. So we substituted in parentheses our value of x, which was 1. That gives us a value of -8. So the vertex is 1, -8. Then we said, okay, we need to fill the rest of the table out. So we need numbers, the two numbers bigger than 1 and the two numbers smaller than 1. And we put those on the table. Remember, I write them from smallest to biggest. Then we took turns substituting those values into the equation in parentheses to find their partners. So I want you guys to take your time and substitute those values of -1, 0, 1, 2, and 3 into the parentheses. So all these that are in the table, substitute them into the parentheses and find their partners. Please pause the video now. Unpause the video when you are done finding the y values that correspond or go with the x values. Okay, check to make sure that you got the same answers as I did. If you didn't, go back and try to see what you did wrong. Maybe you did not use parentheses, or perhaps you forgot the squared. Some of you were forgetting that this signal is a minus, not a negative. Once we have our table, we can make a quick sketch of the graph. Now I know you guys might not have graph paper, so you can just do a quick sketch and plot the points. So -1, 0, 0, -6, 1, -8, 2, -6, and 3, 0. The axis of symmetry, remember, is a vertical line, imaginary line that passes through the vertex. So this equation is x equals 1 because it passes through the x-axis of a value of 1. Remember that the equation for that is the opposite of b over 2a. The equation for the axis of symmetry is the same as for the vertex when you're finding the x value. Okay, so now I'm going to connect the points and make a U shape. Remember, try not to make it pointy. Came out a little crooked. I'm going to try it one more time. Try to make it as symmetrical as possible. Okay. Now, we talked about x-intercepts. An important vocabulary word. X-intercepts are points where the parabola touches the x-axis. The x-intercepts can sometimes be part of the table. So the x-intercepts here are -1, 0, and 3, 0. Today we're going to talk about what those are called and when you don't have a graph. When you don't have a graph, you can find the x-intercepts, aka also known as the solutions of the parabola. So x-intercepts can also be called solutions, except solutions are written with x and equals. So x equals -1 and x equals 3. So you see how I took the x value from the ordered pair from the point and I wrote it but with an equal sign. That's what we're going to focus on today. We're going to find solutions of quadratics by factoring. That way we don't have to make a graph to find the x-intercepts. It's really important for you guys to know that x-intercepts and solutions are essentially the same thing, the same concept. The only thing that's different is how you write them. X-intercepts are points. Solutions have an x equals. Okay, here's our first example for solving quadratics by factoring. Now, in order for me to solve quadratics, it is super, super important that if there's a linear term, so if you have a quadratic term and you have a linear term, you don't have to have a constant term, but if you have a quadratic and a linear term, you have to make sure that they are on the same side of the equal sign. Now this example has a quadratic and a linear term, but no constant term. That's okay. But do you see how they're on the same side of the equal sign? The other side has to have a 0. I like putting smiley faces on my zeros. If all your terms are on one side of the equal sign, you are ready to try to factor. So our directions for this is factor and solve, if possible. Okay, this is a binomial. Always check for GCF. If you notice, these have a GCF of 4n. That means that I could factor this into 4n parentheses n minus 2, and then bring down your 0. Since this binomial inside the parentheses is not a difference of squares, I can't keep factoring it. So I am done factoring. Now, that's what we did in Chapter 7. We factored. But we're solving now. So we need to set every linear factor equal to 0. Pretty much meaning any piece that has a variable to the first power needs to be set equal to 0. So I'm going to set this equal to 0, and I'm going to set this equal to 0. And I'm going to solve. Look at the first one, 4 times n. How do you cancel multiplication? You divide. So you're solving for n. 0 divided by 4 is 0, so there's your first solution. N minus 2, that's subtraction. So if you add 2 to both sides, you get n equals 2. Those are your solutions. Do you remember the problem that we graphed at the beginning? 2x squared minus 4x minus 6. Let's solve that. Now we already know what the x-intercepts were. If you remember, they were negative 1 and 3 written. So the x-intercepts from our table were negative 1 comma 0 and 3 comma 0. Now we're trying to find the solutions without using a graph. We're going to solve by factoring. Right away I notice that this trinomial has a GCF of 2. So I'm going to divide everything by 2. I'm going to be left with 1x squared minus 2x minus 3. This is a quadratic trinomial. So I'm going to try to see if I could find two numbers that multiply to negative 3 but add to negative 2. Go ahead and pause the video and see if you can find those numbers. When you're ready, unpause the video and write them, and let's continue. The correct numbers are 1 and negative 3. I can also use the shortcut to factor, since the leading coefficient is a 1. Bring down the 2 that you took out at the beginning, and we chose a positive 1 and a negative 3 to factor this. Now, normally, if we were just factoring, this would be our solution. 2 parentheses x plus 1 and x minus 3 as binomials. But now we are solving. Because of that equals 0, we need to set each factor equal to 0. However, think about it. Can 2 equal 0? No. Since 2 doesn't have a variable, you do not need to set it equal to 0. Only factors that have a variable to the first power need to be set equal to 0. Now you solve for x. Addition is canceled with subtraction. Subtraction is canceled with addition. And as you see, these are the same answers we got when we graphed and found the x-intercepts, like I told you before. Solutions are the same thing as x-intercepts, except they're written differently. They're written with an equal sign and not as ordered pairs. So remember, the goal of the lesson is to be able to solve quadratic equations by factoring. Let's do two more examples. Okay, here's example number 3. If you notice, we have a quadratic term. Even though it's missing a linear term, we've got all the terms on one side and set equal to 0 so we can try to factor. I'm going to check for GCF. 9 over 25, does that reduce? Try it on your calculator or do it in your head. If it comes out the same, that means the GCF is just 1. So it doesn't seem like there's a GCF besides 1, but I do notice that it's a difference of squares. So I can factor it into two binomials, one with a plus, one with a minus. The square root of 9k squared is 3k. The square root of 25 is 5. I already checked for GCF. I checked for difference of squares, which are my only choices when factoring binomials that we've learned this year. So now I'm ready to set each factor equal to 0. Remember, set them equal to 0 if they have a variable to the first power. So both of these have a k to the first power, so I can set both of these equal to 0. Remember, we are solving, so we're using SADMAP, cancel subtraction and addition first, then cancel multiplication or division. Can you reduce negative 5/3? Nope. So here's one solution. Do the same thing for the other one. Cancel subtraction and addition first, then cancel multiplication or division, and try to reduce if possible. So this quadratic has two solutions. The most amount of solutions that a quadratic can have is 2, because the highest exponent of a quadratic is 2. If we were looking at a cubic function, the most amount of answers they would have would be 3, because the highest exponent of a cubic is 3. Okay, when you're ready, go ahead and write down example 4. I want you to pause the video, check to see if this quadratic trinomial has a GCF, and since it is a trinomial, you're going to try to use the strategy about what numbers multiply to the outsides and add to the middle to factor it. Unpause the video when you're done completing those steps, finding the GCF and seeing what numbers multiply to the outsides and add to the middle. Okay, I checked and there was no GCF besides one for 4 and 23 and 4 and 15. So 4 over 23 didn't reduce, so the GCF was just 1. 4 over 15 didn't reduce either, so that GCF was just 1. Okay, now I'm going to multiply 4 times 15 and find two numbers that multiply to give me that answer. So 4 times 15 is 60, and I need any factors of 60 that add to negative 23. So what I asked you to do when I asked you to pause the video was to do that part. Look for GCF and find two numbers that multiply to 60 and add to negative 23. If you haven't done so already on your own, please pause the video and do that now. Okay, once you make your list of your factors, you should notice that I can use 3 and 20 to make 23. They would both have to be negative. Can I use a shortcut here? So I'm going to split the middle term into a negative 3w and a negative 20w. Remember to keep the 4w squared and the 15 the same. Now I'm going to check it for a GCF for the first two terms. I'm also going to check a GCF for the second two terms. The GCF of the first two terms is just 1w. The GCF for the second two terms is negative 5. In your binomials, you're going to put the first GCF with the second GCF, and then you're going to divide to find the remainders. 4w squared divided by w would be 4w. Negative 3w divided by w would be negative 3. Now we'd be done if the problem asked us to just factor, but we are solving. So now I'm going to set each of these factors equal to 0. Pause the video, solve each one, and then unpause the video to check your answer. I hope you're not just copying me. I hope you pause the video like I asked you to. And those are the two solutions. W equals 5 and W equals 3/4. Just remember that you can't always solve by factoring. I know we said we were only going to do 2 more examples, but I just want to show you that if I ever give you something that looks like this, and I ask you to solve it by factoring, this is a quadratic trinomial. There's no GCF, no GCF, and there's nothing that multiplies, nothing that multiplies to 5 and adds to 7. Right? And the factors of 5, there's nothing that would ever add to 7. There's just nothing that would work. If you can't factor what I give you, then what you're going to say is you're going to say that it can't be solved by factoring. We will learn how to solve these if factoring doesn't work. There's something called the quadratic formula, but we'll learn about that later. So don't say you can't do it. Say you can't solve by factoring, because you can do it. You just don't know how yet. I'm going to teach you later. All right, guys, hope you enjoyed the lesson. If you have any questions, give me a call, or send me a text, or watch the video again. Adios.